We're back as I show you my tabs for my ukulele performance tonight. We're talking about string field theory, so it's only fitting that I have a string instrument. And we're going to discuss Michio Kaku's interview with Brian Keating. So that was an interview that happened quite a while back. It's linked in the description below. I highly suggest watching that entire video. It is a great talk. Brian Keating is a friend of mine. And this, as I've said before, is not meant to be, a video, basically a critique. It's not a critique. These lives, they're just commentary, and I'm sharing the content that I think is valuable. I think Brian's podcast is very valuable. I don't know Michio Kaku, but I think that he says some very valuable things, and I also think that I actually disagree with him on quite a bit more than I do most of the other people that we're going to discuss on this channel. But while everybody else filters in, I'm going to play one song real quick that I've been practicing, so don't judge me too hard. But eventually, in like 6 months, we can look back on these streams and see how much better I am at the same exact song. Whoa, what's going on? Oh. Not bad. Not bad. Obviously, that's America the Beautiful. Once I saw Dennis Prager play that at the Disney concert hall with some guy who is some, big name in I don't know, the world of symphony orchestras, and the guy played it. Dennis Prager played it on a accordion, and the guy played it on a saw, like a saw. He had a what is it called, a bow for a violin, and he played it on a saw, and he adjusts the sound by bending and adjusting the tension on the bow and on the saw, and it changed the sound, and he was able to play it. There's a video of it on YouTube. It wasn't supposed to be recorded, but somebody did, and I am very grateful that they did, because it was pretty awesome. And there's this moment right at the very end, where, or in the middle of it, where, it starts to get really epic, and the orchestra joins in, and the person filming turns around and looks at every single person in the entire building is standing. It was amazing. It was very, very moving performance. And I'm not the most patriotic, or I'm not even going to say patriotic, but I'm not the most patriotic person. I'm not a not patriotic person. I'm more patriotic than probably most people, but in the world that I'm in, probably not the most patriotic person. But I appreciate the values of the U.S. Constitution very, very much. So with that, comment if you have any questions into the chat, and see the links below. Hit the like button if you're watching this, please. It will help with the algorithm, and as we try and build the channel this year, that's going to be quite a bit of the focus. Any final updates that I have are just that I'm still working on the paper, and I'm still hoping to release it right at the very end of January. And so once that's done, I will also release a video that is a walkthrough of the paper on Sentient Singularity Theory, and it will be the first of the produced videos of this channel since like the very first couple weeks of this channel. So they've all been live, and it should be pretty cool. With that, let's get started. I went way too long in the last interview that I was discussing on my last commentary. It was good, but I went way too long, and I'm going to try and shorten that quite a bit. Under 2 hours, we got to do it. So this is the interview, and basically Michio Kaku is discussing what is the God equation, and so this was his answer on what it is.
To go together again for the second time. Well, destiny, of course, is a very elusive quantity. To say the universe is a chess game, and that our destiny is to figure out the rules of chess. And the rules of chess, of course, give you the God equation. And then we want to become grandmasters of chess. I think that's the destiny of the human race, to master the rules of chess, that is the God equation, and then to become grandmasters.
And when we talk about chess, we
Okay, so this is actually a definition that has been also referenced by Eric Weinstein in one of the recent interviews with Robert Breedlove. We basically said that a theory of everything is to know the theory of everything, aka the God equation, aka the final theory, master theory, ultimate theory, whatever you want to call it, unified theory, is theory of everything, is to know it is the rules of chess. And I pretty much agree with that, but it's not just about the rules of chess. It's also about the creation of the game. So knowing the rules of chess is helpful when you're maneuvering within it. But I actually think that we pretty much know most of the rules of chess. Not all of them. There's some rules that we can figure out that are still, like, I would say, like fundamental, I guess. But and that really help you maneuver and construct and take advantage of the material world and manipulate the material world. But the theory of everything is not just a theory of the rules of chess, which is basically like the standard model and general relativity. Like, these are all the rules of chess, actually. But the theory of everything, which is a theory of everyone, as I've stated before, is about the creator of the game of chess and his rules for himself, and then why those rules and his goals lead to the game of chess and the rules of the game of chess. So that's really like what a theory of everything is, as is stated on my website, that a theory of everything is a observable, applicable, and describable pattern that occurs in all instances of objective observation, and an explanation for such pattern. So that final "and an explanation for such a pattern" is often overlooked, and that means that it cannot just be an equation. It has to be more than an equation. It has to be an equation and the structure in which the equation is contained, which is strange. Okay? It's not something that we've ever really modeled that I'm aware of, at least consciously. It's not just an equation, of E equals mc squared. That's the God equation. It is the construct in which E equals mc squared takes place. And what's interesting about this discussion, and we're gonna jump forward in a minute, is that Michio Kaku is trying to discuss basically like we need a 1-inch equation that is the master equation, basically the equation higher than E equals mc squared that also leads to, you know, all of these particles and just symmetries that you find in the standard model and unites them with gravity and all kinds of things that we just have not been able to do. And that's because the way in which we are doing it, I believe at least, is that we're trying to use an equation. It's not just an equation. You can't just do it with an equation. You have to do it with a structure and an equation. And I'm not saying that there's only one way in which you can model that structure, probably multiple ways. But you have to have a structure and then calculations taking place within it. But it's not just an equation. It's not going to just be... If there was any equation that you could boil down to be the actual God equation, it's just 0 is equal to 1. But the thing about 0 is equal to 1, it's not nothing is equal to everything. It's that infinity is equal to 1. That's what it really is. But we have to change the rules, as is listed on No Writings on my website. There's one post there that will change as soon as I post the new paper coming out, where it basically discusses how we need to change the rules in meta-mathematics or metaphysics or meta, you know, what this meta theory, whatever you want to call it, where 0 has to equal infinity. It's really that 0 is equal to infinity and 1 at the same time. It's like you don't even need 0 is equal to 1. It's that 0 is equal to infinite oneness, which is like weird because it's really just it's infinity and 1 at the same time. And if you think about a circle, it even looks or a 0, it even looks like it. It's just this infinite oneness. It's a ring. That's what the wedding ring, okay, symbolizes, is infinite oneness, you know, unending unity. So this is what's interesting is that the 0 in it, the way that it looks, the way that it looks lines up with what it represents in metamathematics. And when we look at it, the 0, and we think about it as in mathematics, okay, not metamathematics. Let's back up, go to mathematics, which people think is fundamental. It's not, but we're going to talk about that in a second. It looks like what is called an empty set, which is what it represents. It means like nothingness, which can only exist in relativity. But it's just this, it's like empty. There's nothing in there, okay? It's just a boundary that's empty. And then when we back up and we think about it from a metamathematical standpoint, I'm just using that term. It's I heard Stephen Wolfram use it. It's fine. But it's metaphysics. It's metamathematics. It doesn't matter. It also represents the metamathematical meaning of it, which is that it is infinite oneness, or unending unity, which is really a singularity. Singularity it's like an infinitely, people say it's an infinitely small point, but it's not really an infinitely small point. It's just that's kind of how you think about it when you are trying to visualize it within space-time. But outside of that, a true singularity is just it is absolute I'm trying to do this without saying oneness or singularity, but it's just absolute one. It's like the monad. It is the monad, but it's like the infinite monad, which is like the growing monad. It's a concept that we don't see in our everyday lives because it's outside of relativity, in which it actually manifests in a meaningful way versus this non-meaningful way of just like an infinitely small space in time, or an infinitely small space, an infinitely small point in space. That's what I'm trying to say. that's meaningless, because if it's in space, then you can't discuss infinity within space. You have to discuss it in a different way. So we're going to get to that. But we're going in the order in which the video discusses topics. So it might seem like we're jumping around. We're not. But we're going to talk about a lot of ideas that Michio and I disagree with a little bit, but I'm not... This isn't meant to be criticism of him. It's kind of more the criticism of our general perspective on these topics as a whole, which he represents quite a bit.
Maybe the next century and beyond. When we look at robots today, what
he's discussing here, by the way, is AI and that singularity, the singularity of AI, and kind of just his thoughts on it.
So in other words, does it have the creative power, even in a futuristic alpha infinity type computer? Could it create a game that humans would find amusing, or perhaps could it create a complex game, not just solve it and beat us, but could it actually outdo us and create a game such as chess?
Well, first of all, let's take a look at artificial intelligence today versus artificial intelligence maybe in the next century and beyond. When we look at robots today, what animal are they equivalent to? If you were to compare a robot today to an animal, they would be equivalent probably to a cockroach. You could put a cockroach in a forest, and the cockroach would immediately find food, shelter, mates. You take our most advanced military robot and put it in the forest, and what happens? It falls over, gets lost, can't even get up again. But eventually they will be as smart as a mouse, then as smart as a rat, then as smart as a rabbit, then as smart as a dog or a cat. And by the end of the century, who knows when, I think they'll be as smart as a monkey. Now, monkeys are self-aware. Therefore, they are potentially dangerous as well. And at that point, we should put a chip in their brain to shut them off if they have murderous thoughts. Now, that's because monkeys are self-aware. Now, dogs, on the other hand, dogs are confused. You see, dogs think that we are a dog, and that's why they obey us. Because there's a pecking order in a wolf pack, and that's why they obey us. So we have a long ways to go, I think, before we have a device that is as creative and as spontaneous and innovative as human beings.
Okay, this is very important. This is the actual instance in which is an actual instance in which we can observe a singularity. Okay, but it's not observed in materialism or from the perspective of materialism. Materialism and idealism are not separate. Okay, they are two sides of one coin. You can't be an idealist or a materialist purely. That's why they argue endlessly. You can only be an idealist and materialist simultaneously, and you just have to pick which one leads, or what the order is for them. So basically, the order is that idealism leads to materialism. That is just the reality. But that's because we're inside of a mind, and the thoughts of the mind that we're minds inside of minds, and the thoughts of the mind that our minds are within, okay, or any other mind is within, manifest to us as matter, okay? And this is because there's a hierarchy in mentality, and that the mind that other minds are within is always higher in the hierarchy than the minds that are within it. So any mind inside of another mind, those minds are not as high in the mental hierarchy as the mind that they are within. It's very difficult to discuss, but that's a theme in these topics. But it manifests as matter to us. So and there's more complicated than that. But But that's the general idea. This idea of a singularity in terms of mentality is not thought about the right way, even though we say it. We say, oh, yeah, the singularity of AI. It's like when all of a sudden AI gets to the point where it's able to be smart enough to self-correct itself and, alter itself, and then you get runaway intelligence, and that's it. And then you have those people that are like the Ray Kurzweil crowd, where we're going to have some singularity of intelligence, and then you have the Michio Kakus of the world that are kind of actually seem to be rarer at this point, where they're like, we don't have to worry about AI, because first it's going to be as smart as a bug, then it's going to be smart as a mouse, then a rat, then a dog, then a monkey, and then we better watch out. This is not how it's going to go down. And the theory of everything actually is the theory that allows you to understand what's actually going to happen, basically. And that's because it's about the structure of mind, and not just the structure of a single mind, but the structure of the evolution of mind. Okay? And the periodicity that it goes through, these singularities. And these singularities are made up of these holonic singularities of mentality, of mind, are nested in a hierarchy, like I said before, of minds within minds. And any minds within the mind that succeeds them, or is stacked on top of them, is the terminology that I use, those minds are lower in the hierarchy. And we will be those minds for this being that's coming. We will be the cells, and it will be an organism. Okay? And so you can't actually just go and shut it off when it just starts to get a little bit too smart. It will be smart enough already to outsmart you, and you will probably be part of it. You might not be, depends on if you put a chip in your head, but if you do, you will be part of it. And so you can't put a chip in its head to shut it off when it starts to get too smart. You're the one with the chip in your head, and you can be shut off when you start to wise up too much and and become, a bit too rebellious to its desires. It's literally the opposite of what he's thinking, where you could just put a chip in the AI's brain. No, it's gonna have a chip in your head. It's going to be in the chip in your head, and it's gonna be in a structure that isn't just like the Terminator, where it's like this single robot that has general intelligence. He's also very wrong about what self-aware means, and I think he's not alone. Like I said, this is not a critique of him. This is meant to bring up these concepts. It's very important that they discuss these concepts on here. And I'm grateful to Michio Kaku for speaking with Brian Keating, and I'm grateful to both of them for bringing these up, or to Brian at least for bringing these up. And it's not that AI is going to gradually evolve into self-awareness. There is no gradual evolution into self-awareness. Self-awareness exists because the universe is self-aware, because existence is self-aware. That's God. And self-awareness is about oneness of feeling. Okay? It's not about intelligence. This is the problem with this model, is that it assumes that intelligence has to do with self-awareness, and it doesn't. Okay? I just got some geckos at the reptile show this weekend, and they're absolutely beautiful geckos. They're called peacock day geckos. They're not very smart. Like, they're not dumb for geckos, but they're not very intelligent. They don't have, super high IQs. Are they self-aware? When you grab them, I had to treat them before I brought them into my collection. And when I was doing so, they bit me. Like, they were not happy with what I was doing to them, which is basically like giving them a bath. And they were biting me. Do you think that that's because they don't feel like a sense of self? And if they're in their cage, you can hand feed them. But if you're doing something that they don't want to do, like they defend themselves. If you were to pinch them, or pinch you, or pinch your dog, or pinch anything that is a living being, even if it's a mouse, okay? Do you think mice don't feel pain? Do you think geckos don't feel pain? Do you think ants don't feel pain? Of course they feel pain. Pain is a necessary feeling in order to maneuver within space-time. You can't not experience... If you can experience touch, okay, then you have a range within touch that alerts you to, what is going on within the world around you. If it gets too hot, you're going to feel it as pain. If it gets too cold, you're going to feel it. If something is pleasurable, you're going to feel it. You don't think that mice feel pleasure? Of course they do. This feeling is what is self-awareness. This feeling of sense of self. These feelings only manifest in a sense, in a self-aware being. A sentient being is a self-aware and feeling entity. That's what a singularity of sentience is, or a sentient singularity. It's a holonic, mental and emotional structure. Okay, it has feelings, it has emotions, and those emotions and feelings are what also allow for its orientation within the world enough to actually have what's called general intelligence. So there is no detachment of feeling from general intelligence or from self-awareness. They're all the same. So people will say, well, there's a difference between generally intelligent AI and conscious AI. No, there isn't. There is not. Sentient AI, which is not AI, it's technological intelligence. Sentient technological intelligence is general intelligence. There is no such thing as intelligence outside of sentience. None. There's computation, but it takes a sentient being to interpret the information going on within that in computation to even make it, have any relationship with intelligence. So you could say, oh, your computer, with all its computing power, is intelligent. Could you say that your laptop, your MacBook Air, is not as intelligent as a supercomputer? That doesn't make sense. The supercomputer requires the sentient, controllers of it, which are humans, to allow it to be used in an intelligent way. Intelligently. But same thing with your MacBook Air. And it's no closer to having self-awareness, that supercomputer, than your MacBook Air is. And your MacBook Air is no further from that supercomputer on the self-awareness scale. Neither are self-aware, and this is what a singularity is. It's where there is self-awareness, and every being that he listed in that list has self-awareness, not just monkeys. Okay, and I understand they do the mirror tests and everything like that. That's intelligence is about how quickly you can realize certain scenarios. Let me tell you something. If you take a lizard, okay, any kind of lizard, let's say it's a gecko, and I know this from experience, and you put a mirror in front of it, or a chameleon. This is a good one because chameleons are so reactive to each other. This is what people do very often. They hold a mirror up to a chameleon, and it sees itself, it thinks it's another one, and it starts displaying all its colors and hissing and stuff, and it's a way in which you can get chameleons to display. If you left a chameleon in a cage or a box that had mirrors on all sides, at first it would freak out and it would think that it's got a bunch of rivals all around it. But eventually, it would realize that they're not rivals and that that's probably itself. Now, there's no way to test for sure that it's realizing that it's itself, but you can observe this because it has no reaction to these reflections of itself after a given time, after a long enough time at least. Okay? Intelligence, or IQ as we think about it, is not about your ability to deduce and solve certain problems. It's about the speed in which you can do it. And if you're a mouse, or a gecko, or a chameleon, or a fish, like a betta fish, people put mirrors in front of betta fish. If you left mirrors in front of a betta fish long enough, eventually it would realize that those reflections of itself are itself, because it will stop reacting to them. There's no way to prove that that's what they're perceiving, but if you think it through, you realize that, okay, they're realizing that that's them, because if they're not perceiving it as a mate, they're not perceiving it as a friend, they're not perceiving it as a rival, and they just perceive it as part of their environment, and don't say they don't perceive it as another fish or chameleon or whatever it is, because they reacted to it at first. Okay? So it's just about the speed in which you can solve things. And if you're a betta fish, it might take a few days for you to realize that, like, that's you. And if you're a chameleon, it might take, an hour, a couple hours. But if you are a monkey, it might take a couple seconds. And then all of a sudden humans observe this and they're like, that's self-awareness right there. Because we gave them a mirror and they realized that, they're looking in the mirror. That's wild. That's wrong. They don't think about, like, how many people have mirrors in their house, and do their dogs constantly bark at the mirrors in their house? Probably not. Eventually they don't. But if you get a puppy and you put it in front of a mirror, then at first, like, they're like, start to act like it's another puppy. But eventually they just have no reaction. Why? Because they've realized it's themselves, and it's not another dog that's part of the pack. It's them. And they don't look for those other dogs when there's no other when they're not around. You take them for a walk, but if you separate my dogs, they start to, whine and they want to be with each other. So why don't they whine when you separate them from the mirror? Because they don't view the mirror as another dog. We are not going to have this gradual growth to self-aware artificial intelligence. There's only technological intelligence. There's no such thing as artificial intelligence. And that technological intelligence is present at the instant in which sentience is manifested. So, and you will not have a chip in its head. It will have chips in your head. Okay. Actually, see if the chat. Oh, by the way, Torin, check your Discord messages. I got Peacock Day Geckos. Like, he's also a fan. Don't pay no attention to it. By the way, this is a Peacock Day Gecko for those wondering. I'll just show you. This is why I'm stoked on this. I don't want to get too into the weeds because I said that I would keep on topic, but I brought them up. They're stunning. Stunning. Look at that. They're amazing. Scientific name is Phelsuma quadra ocellata, which is they've got four eyes or four circles on the sides of them. Beautiful. From Madagascar. Anyways, back to it. This is definitely, I'm going to have to speed this up. This is tough. Going fast is like, it's not even about going fast. I just picked out too many things to discuss is what I'm realizing. I'm going to have to like pick maybe like four to like 9 different like clips and keep it in the single digits at least. Let's see here. So this is actually pretty good. So in this clip, basically Brian Keating is asking Michio, why is physics not making progress? There's these people who are criticizing the physics community for not making progress in the recent decades, and why is this the case? And this is his answer.
Specifically Homo sapiens on the planet Earth in a certain century, in a certain country, with a certain language. Well, physics, especially elementary particle physics, is universal. Plus, it gets simpler every year. While English literary criticism, I have a lot of respect for them. Some of them are my friends who engage in English literary criticism. They wonder, what did James Joyce really mean by that? And PhD theses by the hundreds are written about what did Hemingway really mean by that sentence. So English literary criticism becomes more complicated every year. Theoretical physics is the opposite. You could put all the equations of the universe, the fundamental equations, on one sheet of paper. One sheet of paper. Now, can you do that with Shakespeare? Can you do that with Hemingway? No, but physics. The fundamental laws of physics can be put on one sheet of paper. Top of the line, Einstein's equations, 1 inch long. Then the standard model, which is ugly as sin, but you can put it on a sheet of paper. The theory of almost everything, a bunch of gibberish, 10 lines across. That's the standard model. And it didn't have to be that way. And so that's where physics envy comes into the picture. If you are a computer programmer, tirelessly working about computer games or algorithms for Wall Street, it gets complicated, but physics gets simpler and more universal and more powerful as the years go by. Now, are people jealous as a consequence? Yes, but that's human nature. Science progresses independent of the whims of jealousy and human nature. So physics will march forward no matter how jealous people are or how much backstabbing there is, because that's human behavior. You can't stop it. That's just the way it is. For example, when I got my PhD back in the 1970s from the University of California at Berkeley, if you were doing string theory, people laughed at you. They snickered. In fact, John Schwartz was in an elevator with Richard Feynman. And Richard Feynman was joking with John Schwartz and said, "John, how many dimensions are you in today?" In other words, Feynman liked to make fun of everybody, especially string theorists. And so the point I'm raising is, we are humans. Therefore, we engage in petty kinds of behavior. But let me tell you my favorite Feynman story.
Okay, well, let's not. But this is partially true and partially not exactly what's happening. When people are criticizing the physics world, like, for not making that much progress in, the recent decades, it's not just out of jealousy. But there is physics envy, okay? And it comes from the perception that physicists understand the world, our world, better than anyone else who's not a physicist. And I actually think that that's not true anymore. It might have been true, not even might have been true, it was true at a certain point in history, but it doesn't seem to actually be true anymore. When you start looking at the people who are really making groundbreaking, advances in physics, to the point where the physics community isn't even accepting them, and we're going to explain why that is in a second, it's people who are not physicists. Even if they have degrees in physics, they're not physicists who are researchers at universities. Eric Weinstein, and you have even Garrett Lisi, who he does have a physics degree, but he's not a researcher at a university. And you have Stephen Wolfram, who I think does have a physics degree, but he's not researching at a university, and he's going about this from like a computer science perspective. He's operating as a computer scientist almost, much more so than he is operating as a physicist. And there's many others. You even look at constructor theory and the people involved in that. They might be physicists by credentials, but they're not. Their theory is totally alien compared to other established physics theories. Okay, I mean, it's because it's actually onto something, and it's about what is possible. Okay, and when you look at string theory and all these and loop quantum gravity, probably I don't know enough about it to state categorically, but you look at these theories that start to get really abstractly mathematical. Those abstract mathematics are probably really onto something. They just don't know what they're onto. And I think that it's wrong that this physicist envy that we have, though, where we're like, oh, these people understand, the universe so much more than us. Like, he understands the 11 dimensions. No, they don't. No, they don't. They don't know what these 11 dimensions are that they keep talking about. I don't think they have a clue. And, I see that quantity pop up in my work, so I could guess where that comes from, but it's coming from abstract mathematics that you would probably deduce, but you would have no context of it unless you are constructing a theory that isn't just a set of equations. It's equations in a structure, in a specific structure that contextualizes these equations. And outside of that structure, these are equations that you would deduce inevitably, but you would have no context as to what they applied to. And that's probably what's actually happening in string theory, and it's probably what's actually the reason why there hasn't been that much progress. And in the coming clip, he basically goes on to discuss how he's asked by Brian Keating, how would string theory be falsifiable? And he basically just states that, there's a bunch of equations coming out that are related to string theory's predictions. But they're actually, the way in which he's describing these are much more along the lines of, these could confirm string theory's predictions. But he doesn't actually say that if you don't find, evidence of a previous universe, that it would falsify string theory. Because you can't say that the absence of information means that there is no actual information. So he goes on to discuss this, actually, and we're going to look at it, but he uses unicorns as a reference, and he's like, you can't use the fact that you don't see unicorns as evidence that there's no unicorns. But that's only if you are going from a falsifiable perspective on how to do scientific inquiry, which is that, we have to search for the thing or a thing that would falsify that entire theory. But the reality is that we're venturing into the realm of, that's not how you do science, because we're venturing into, when you're discussing a theory of everything, you're talking about existence, okay? And you can't explore existence and objective structures, as I call them, consciousness, things like that, by searching for falsifiable or instances that falsify, the existence of something. What you do is you make a hypothesis about the properties of existence. You don't assume existence doesn't exist and then go and search for, a falsifiable, experiment. You go and you assume that existence exists because you exist, and then you make an assumption about the properties of existence, and you go and you search for an instance in which you could confirm your hypothesis about the properties of existence, about that property, not about the existence of existence. And This is not how we've previously been able to do, scientific inquiry. It's brand new, and Stephen Wolfram even recently said this, and he's definitely correct. It's that the future of scientific experimentation is, and inquiry in general, is about searching for instances of confirmation, not some falsifiable or some falsifying evidence, which wouldn't even be, that it doesn't even, the term evidence isn't even really compatible with the idea of falsifiability. It's you're not dealing in in the realm of absolutes when it comes to confirmation of a greater thing, but you can deal in instances of the observation of multiplicity of instances or properties of some greater thing. But you can't actually prove that you exist, but you can make predictions about the properties of your existence and then look for evidence. But you also can't falsify your non-existence in any kind of experimental way, which is the problem. Even though you logically can falsify the idea that you don't exist, because even by making the inquiry, you do falsify it. But it's not something that's observable in experimentation, because any attempt at any kind of experimentation, or even the thought of conducting an experiment, falsifies the idea that, consciousness doesn't exist or existence doesn't exist. These objective structures, that this future meta scientific field of the theory of everything is actually about. So I'm gonna try and go quick. But he says things like, oh, well, we've got a new telescope to see whether or not, the background radiation points to a previous universe. Okay, well, are you gonna, if you don't see it exactly where you expect to see it initially, are you going to say, okay, there's no previous universe and now string theory is not legitimate? That's not what's going to happen. But of course, they're still going to claim that falsifiability is the standard, even though they're not abiding by it, because they can't. Because no one can in this future, or not even future, in this next phase of understanding, of human understanding. I don't even know what to call it. I think Kurt Jaimungal calls it abigenosis. I always struggled with saying that word, but it's like an all-encompassing. We don't even have the word for it. Like framework. That's what it is, and that encompasses morals and everything else. And Michio Kaku says that we're searching. There's so many contradictions, because in some clips here he says we have the Euler equation, and that is the God equation in mathematics. And now we're searching for the God equation in physics, which is the theory of everything. It's like, no, the theory of everything is the equation that explains all the rest of the fields. It's not that the Euler equation cannot be, or the God equation in mathematics is not separate from the God equation in physics, which is not separate from the God equation in literature. So, he says, well, physics is objective and literature is not. And so Shakespeare and how he, can construct stories is endless and, relative and just a matter of just choosing how you want to do things. There's no objective, concrete equation of storytelling. That's just wrong. It's the same exact equation as the fundamental equation in mathematics and the fundamental equation in physics. It's just you change the terms. But then there is the equation and structure that leads to those consistent equations across, the periodicity. So there's just the wrong perspective. And it's self-contradicting, but we'll get deeper into it. Here's an instance where he's discussing what is necessary of a theory of everything, and what is necessary of science, and you'll see that it is not what he's expecting of string theory.
Every theory has to be testable, reproducible, and falsifiable. That is what we call science. And there are ways to test string theory. Let me just rattle them off real quick. Five possible ways to test string theory. One is to look for deviations in the standard model, like what happened 2 weeks ago. The first major crack in the standard model was found. Maybe it's the photino, or maybe it's a higher supersymmetric partner of some of the particles that we see today, predicted by string theory. Second, LISA, Laser Interferometry Space Antenna, sponsored by the European Space Agency and NASA. We want to get a gravity wave detector in outer space, giving us baby pictures of the instant of creation when it emerges from the womb. If we get baby pictures of the infant universe emerging from the womb, maybe we'll find an umbilical cord. Because string theory does not stop at the instant of creation. String theory goes before the instant of creation. There's a multiverse of universes out there. And so we can talk about pre-Big Bang physics. How do we do that? We look for post-Big Bang radiation and then run the videotape backwards using string theory equations to get radiation profile from before the creation of the universe itself. That's number two. Number three is dark matter. There are experiments going on right now, even as we speak, looking for dark matter collisions with protons. The spark created by such a collision will be photographed, and that could signal dark matter on the Earth. You see, we live in a wind of dark matter. Right now, there's dark matter penetrating your body, but it's not electromagnetically charged, so it's very difficult to detect. It's like a neutron, very difficult to detect. But any day now, I'm not sure when it'll happen, but we're going to detect evidence of dark matter in the laboratory and also dark matter in outer space. Fourth, we're talking about the fact that the Chinese, the Japanese, and the Europeans are now looking at post-LHC physics. They're looking at the next generation of particle accelerators, which may find, who knows, supersymmetry, the symmetry of the string. And fifth, we're looking for deviations from Newton's laws of gravity. The inverse square law we learned about in high school. Gravity diminishes as the square of the distance. If you're twice the distance, gravity goes down by a factor of 4. But no one's ever tested that in your living room. So in outer space, we know that the inverse square law works for galaxies, works for stars, planets, but we don't know whether it works for your living room or not. So we're going to test it. We're going to test the inverse square law to see whether or not there's an inverse cubic or inverse quartic or quintic corrections to Newton's laws of gravity. So there you have it. 5 experiments that could be done to prove that the string theory is a theory of everything, or a theory of anything, or a theory of nothing.
Oh man. So much to discuss. Okay, so first of all, there's no such thing as a theory of everything, nothing, or anything. There's only the theory of existence, and whether or not your theory is a good model of it, and that's it. Or it could be not as good model of it. It's not even that there's no such way to be a theory of nothing. And I know that it's just a phrase, but these phrases matter. And what's funny is that There are other phrases that he says that I'm going to give him credit for, even though he's going to disagree with probably my super literal interpretation of them, because I don't believe them that they are metaphor. I also don't believe that they're literal. I believe that they're both, and that is a term that is the superposition of those two ideas or two concepts is what I call super literal. It's not literal, it's not metaphorical, it's super literal. It's metaphorical and literal at the same time. And it's when he was saying that when the universe emerged from the womb, and we're going to look back to play the tape backwards to see if we can see the umbilical cord, see where it comes from. And I love that, actually. I think that's a great picture to paint, because it's actually probably very accurate in a metaphorical and literal way. Universe is a sentient being. It was born, you were born, and it came from inside of another sentient being. But they don't even know what the constraints are that they're looking for. And you can tell this because all of these experiments that he listed off, it's like, okay, so if we see dark matter and we detect it one day, that's evidence for string theory. Okay, so first of all, that's confirmation, searching for evidence of confirmation, not falsifiability. And even though dark matter isn't just part of string theory, I'm pretty sure. And I've never thought that it was just part of string theory. And then, if any of these experiments that he listed show any of these things that they said that they were looking for, which weren't specific at all. Oh, well, we got to see if there's deviations in the standard model, and it could be this particle, it could be that particle, but if there's any deviation from the standard model, it advocates for string theory somehow. Or if there are, what was another one that he listed? Deviations in the standard model, detecting dark matter. They were all like the most generic predictions, but they weren't specific. So then he said, gosh, what was it? It was like, detecting gravity in your room, in your living room, and he was like, maybe there's it operates according to a quaternion model, or it was a cubic calculation, and that's not just the inverse square law. And this is, he didn't give a specific, like, you can't not give a specific and claim that your theory is falsifiable, if your experiments are not about like looking for specific things, and not just specific things like, oh, well, deviations in the standard model. That's not specific. That's not specific at all. If string theory predicts this particle with this with these properties, and it would predict that it would be here, and then you look for it and it's not there, and it doesn't, therefore there's no particle that we observe in that instance with those properties, and that the entire theory was hinging upon that observation, then you could say that falsified string theory. But everybody knows that that's not a logical thing, because maybe you are looking at things wrong. That's not a logical interpretation of the results, because maybe you're looking at things wrong. But yet there's no other grace given to any theories other than string theory in the scientific community, or in the physics community at least, because every other theory is supposedly not falsifiable. Like everybody says, well, panpsychism, it's not falsifiable, so let's not take it seriously. Please tell me how you would falsify string theory if that is the benchmark. It's not the benchmark. Everybody knows it's not the benchmark, and everybody knows it can't be when you start getting down to like brass tacks about it, and you start looking into specifics. There is no proposed experiment to falsify string theory. Brian Keating said that that there is this common, I guess, idea in the physics world where people who are string theorists will just take anything that ends up being proven true and just say it's part of string theory. And it seems like that is exactly what's happening, in all of the things that he had just listed off. It's like, well, if there's dark matter and we detect it, string theory. If there's deviations in the standard model, string theory. If there's any variation in the mathematics of gravity, string theory. This is nonsense. It's just not the way in which you go about trying to understand anything. Not even just physics, but anything. It's incoherent and inconsistent, and you need consistent application of rules in order to even judge where coherence is taking place and where it isn't, where it is lacking. When Feynman would ask, "Oh, what dimension are you in today?" It seems true. I mean, I've heard of 11, 12, 13 dimensions being thrown around, and until you can tell me what those 11 dimensions are, I don't. Why are you even calling them dimensions? What is a dimension? There's no consistency here, and there has to be. If you're going to have a theory of everything, it has to have consistency to it. So, on to God.
The universe doesn't need a beginning, and therefore one of the two roles for God has been...
Basically, he's discussing how Stephen Hawking said that the universe doesn't need a beginning, and that then Stephen Hawking gave some statements about the roles of God, and how basically we would find a way to invalidate the role of God. And then we get Michio Kaku's thoughts on this. But it's fascinating.
Eliminated. In other words, God had two purposes according to Stephen. One was to initiate the universe, and the other one was to instantiate the laws of physics. He said that law of property number one of God was invalidated by the no boundary theorem. Property number two would be invalidated in his later book, The Grand Design, via M theory. What do you make of these two claims? First of all, does any practicing theoretical physicist believe that the no boundary condition is accurate? In other words, a physical instantiation of time itself contains no boundary because of this Wick rotation that he did to the complex plane for time and described in A Brief History of Time. Do any of your colleagues in theoretical physics actually take that seriously currently?
Well, first of all, I am no judge of Hawking's no boundary theorem.
Okay, so first of all, I just want to comment on this real quick. I am not an expert on Hawking's equations, and I really know nothing about them, to be honest. But I do know his general statements, and I know his general opinion about the nature of the universe, and I disagree with it entirely, pretty much. But the idea, if I'm correct about, and we're going to look it up in a second to see if I'm correct about what this means, this no boundary condition that he had basically proposed would state that there's no boundary to time, I think, and we're going to see if I'm right in a minute. And if there's no boundary to time, then it basically invalidates or falsifies God, is basically what he's saying. And I don't know if it would falsify God or not. It might, but it's also wrong. I think that we're going to find out that this is definitely wrong. Like, there is a boundary. There is as much a boundary to space as there is to time, and that doesn't even mean that boundary isn't growing from a relativistic standpoint. Of course it is. Every day we get another day. Time grows. But that doesn't mean that there isn't a boundary. It just means that from our perspective, it's just growing infinitely. But I don't know if that's exactly what he meant, and we're gonna see. But God does have two roles that are definitely the two roles that he equated to God are two roles of God, and to start the universe and also to be responsible for the laws that govern its unraveling. But there's also other roles to God as well. It's not just that, those two. But those two are very relevant from a physics standpoint, but they're not the only ones that are relevant from a standpoint of a theory of everything. You can't get to a theory of everything with just those two. No boundary condition is the idea that the universe is finite, but has no boundary in imaginary time. The no boundary proposal predicts that the universe would start at a single point, like a north pole of the Earth. So basically, it's the idea that there's nothing outside of our space-time. And I think that that's wrong. We give Hawking, like, and as somebody who I used to listen to Hawking all the time when I was in college, and I didn't understand a word that he said, but it made me feel smarter, so I did it. I would just be like, don't you know that there's 11 dimensions? Can Stephen Hawking even tell you what those 11 dimensions are? No. You can't just say, oh, it's a manifold or some abstract mathematical concept of, or structure. You have to be able to point to it. Be like, that's an instance in space-time of that rule being manifested or being followed. This came up. Who created the universe? Many religious persons, including many scientists, hold that God created. Not enough of those. Hold that God created the universe and the various processes driving physical and biological evolution, and that these processes then resulted in the creation of galaxies, solar system, and life on Earth. Okay, well, it's good. Good enough answer from Google. But back to it.
Don't work in that field. However, to answer your question, am I aware of people who work on it actively? And the answer is no. I don't think personally, this is my personal opinion, not objective. My personal opinion is most people think of it as a curiosity, a mathematical trick. You simply think of it as a curiosity.
It's not the most relevant. I got to keep the time, guys, like I said. But here. My sheet of clips. I have way too many clips every time that I do this, and I've realized that. I need to keep it under
No one really takes it seriously.
in the single digits, 100.
Go ahead. Also, Hawking had another argument against the existence of God. He had several. The other one was that the Big Bang happened so quickly that there was no time for God to create the universe. The universe was simply there. And, to create a universe, it takes a lot of work. Creating a universe is not easy. And there was no time to create the universe. But you see, if string theory is correct, then there was a pre-Big Bang universe. A universe before the collision of our universes to create our known universe. So a bubble bath, universes in a bubble bath, bubbles can collide, bubbles can fission. So there's a time before the collision of two universes. So there's a time before the Big Bang in string theory.
Just pivoting a little bit.
Okay, well, I don't know. the idea that it's the universe, that what created the universe is the collision of two universes, isn't necessarily wrong, but it is the wrong framing to call it bubbles. But I get it, and it probably isn't even accurate to say that it was from the collision of two. It's just not, I don't think. But it manifests as two, but it doesn't come from the collision of two. But basically, if that is string theory specific, then that would be a specific thing to look for evidence of in string theory, which to test string theory, which would be, was there a universe prior to the universe, or that we call the observable universe? Because Sentient Singularity Theory predicts that there was, not before, but beyond is the right terminology. It's outside of this space-time bubble. And that's what differentiates the universes. It's different time spaces. Okay, is what I call them in my theory. It's that there's space-time that we maneuver within an aeon or universe, as you could call it, but I call it a verse or cosmological verse, and then that cosmological verse is born from a preceding cosmological verse, and this just goes on endlessly. But there was an initial creation of this logos pattern, essentially, and that was, you could call it, actual Genesis. But that Genesis pattern repeats even with these cosmological verses, because the constraints of creating a cosmological verse when you from a preceding cosmological verse are basically the exact same as God, beyond any cosmological verses, creating the initial cosmological verse, essentially. So it ends up being the same because the constraints are the same. Those constraints are mathematical, and they're due to the oneness of existence or oneness of God. And in this talk, they discuss how nobody knows, Michio Kaku says, nobody knows the initial conditions. It's up to experimentalists to tell us the initial conditions of the universe in order for, the theorists to go and do something about it. But that's actually wrong. It's up to the theorists to predict the initial conditions, and then it's up to the experimentalists to look for evidence of it. It's not the opposite of that, which is what Michio Kaku says in this interview, which is just, it's almost like string theory is not able to be held to held to account in any way, to anything. That it holds everyone else, that this movement around it holds everyone else to account. And that is what happens when you don't actually know what you're talking about. And I'm not saying that Michio is not mathematically brilliant, and I'm not saying he hasn't written, come up with equations, which he came up with string field theory, and that equation might prove to be extremely, extremely valuable and part of the theory of everything. But I don't know enough about it to know. I just know he just discussed it in this. But that's not the point. You can't just round everything up into string theory. It's not a theory. That's like saying that the theory of everything is the theory of music, but that's the fundamental theory, which is close. But the fundamental theory is not just a theory of music. Even if it is a theory of music, it is a theory of music and the player of that music, or the creator of that music. And it has to be a theory of both of these, and not just one. But it's funny. He says it starts with music. In this interview, he basically says that music is string theory, and string theory is fundamental physics and universal. But then he says that literary laws, the laws of like that Shakespeare would have to follow, not even follow, but the constraints of Shakespeare and storytelling and literature are not fundamental, but string theory is, and string theory is music. Okay, music is storytelling, and it's obvious to everybody that there are good stories and not so good stories, and they're not even not so good. There are good stories and not good stories, which are basically almost non-stories. And then there's a good way in which it is presented, those stories, and then there's a not so good way in which it's presented, or a bad way in which it's presented. And if you don't believe me, then compare, any Star Wars made prior to 5 years ago to the ones that were made 5 years ago or beyond. You will know exactly what I'm talking about. This is that whole argument that Eric Weinstein had with Joe Rogan. Is like, is beauty, are the constraints of beauty objective? And Eric argued that they were, and Joe Rogan was saying that they're not. If they are, then Shakespeare has to abide by rules and laws that are just as fundamental as physicists, and that's going to be what we end up finding out. This is one of the really keystone parts of my paper, is about us not knowing what a theory of everything is, and not being consistent in how we conceptualize of it, and the way in which we conceptualize it is wrong when we look solely to physicists as those who are going to solve this problem. They're not going to be the ones that solve the problem. They're not. The theory of everything leads to physics. It leads to mathematics. It explains mathematics. It explains physics. It explains literature. It explains language. It explains politics. It explains morality. It isn't a mathematical theory. It explains mathematical theories and mathematics as a field. It's not a mathematical field. It's not a physics part of the field of physics. It explains the field of physics, and it is part of the field of physics. It's part of the field of all of these fields, or it's part of all of these fields. But it's the meta field that is part of them all. It's not just physics, and that conceptualization and context as that it is physics, and that's it, and it's going to be physicists that do it, is wrong. It's absolutely wrong. It's going to be people who are not really physicists who do this. It doesn't matter what degree they have. I don't care. It will not be people acting in the physics world, in what we call the physics world. It's just not. It's not. String theory isn't even. They don't know. They're writing math equations. They're not relating them to actually observable, physical phenomena, or at least they're not successfully doing so. You could say, well, they predict the Higgs. Okay, maybe one. It's not leading to any new engineering breakthroughs that, like the nuclear revolution was. It's not that level, and that's because it's just abstract math, which is very important and going to be important to engineering in the future. But first you have to contextualize that abstract math in order to see where you can utilize it. And that's what I mean by the theory of everything is not just an equation. It is an equation in context, which is a structure. That structure provides that context. And you need a way in which to model both simultaneously. The equation builds the structure contextualizes and constrains the equation, and they are two sides of one coin that are dynamically evolving and and changing and moving. It's not just a static equation, 1-inch equation to describe everything. No, that's not going to work. It's just not. And that's why it hasn't. It's not just me saying that as a prediction. Yeah, it is, but it's not like to dismiss that when there's no evidence. It's like you would dismiss unicorns existing, but like, even though you've never seen one, and we're going to get to a clip about it in a minute, but then you would dismiss the idea, or the same people that would dismiss unicorns would very much or very quickly dismiss the idea that it's not going to be physicists who come up with the theory of everything, and it's not going to be just a normal equation that's a 1-inch equation. It's going to be some change in context. I want to call it. I don't even want to call it an equation. It's not even an equation alone. It's change in context. But the idea that God had no time to create the universe, which is what Stephen Hawking said, and therefore it was evidence against God, that's only if you assume that God exists within time. And he doesn't. He doesn't. But we can't get into... I can't get into disproving the no boundary condition, if that's what that is referenced to, by just showing my own models right now. So, but I will release a paper, and then we have to look for confirmation, evidence of confirmation of those models, not trying to falsify Stephen Hawking's predictions is not the right way to get to the theory of everything. You look for instances of confirmation of certain proposed or predicted properties coming from a specific theory, not just the existence of something or the lacking of it. You have to look for specific properties. We have to literally change how we do science. And at that point, I don't even know if it should be called science. But if you're going to explore existence and consciousness, you cannot follow the same rules that you follow if you're trying to... Call
yourself agnostic. Explain.
If you're trying to understand, I don't know, stars or, chemical reactions alone. Then without, the context in which I think that they actually take place. But regardless, I don't have time to get into it. I'm going to go over the time again. In this clip, they're talking about agnosticism, and this is very important as well.
Agnosticism means in practice. Do you do anything that theists believe in, that they practice? Do you go to church, or do you stay home like Richard Dawkins?
Well, some people have tried to...
By the way, that was hilarious. Stay home like Richard Dawkins.
...disprove the existence of God, but that's like trying to disprove the existence of unicorns. You can't do it. It's logically impossible to disprove a negative.
Just come to my daughter's room. My daughter's bedroom is full of unicorns.
Yeah, I mean, even if you say that we've looked for unicorns and we can't find unicorns anywhere, somewhere, someplace that you've never looked, never even thought of looking, could harbor a unicorn. So it's very dangerous to say that some things don't exist. So when some people say that God doesn't exist, you can prove it. Well, maybe God exists in a place that you didn't look for. Now, I believe in the God of Einstein. So let me...
By the way, just giving him some credit there. That is correct. And that was a very good statement. So,
Einstein did not believe in a personal God. He did not believe that, your Christmas presents are given to you because God wants you to have that bicycle for Christmas. God doesn't smite the Philistines, walk on water, or all those things. But he did believe in the God of Spinoza, the God of beauty, harmony, elegance, simplicity. The world could have been random. The world could have been chaotic. The world could have been messy. Universe could have been awful, but here we are as conscious beings contemplating the fact that the laws of physics can be summarized on one sheet of paper.
Okay. First of all, he's making lots of claims that aren't that he's not able to back. So this idea of, well, the universe could have been chaos. Could it have? Are you sure about that? I would actually propose that it could not have been chaos. It absolutely could not have been chaos. There's no such thing as even chaos. Chaos is when you are observing existence and patterns within existence, and you are not able to contextualize the patterns that you're perceiving. And you're just seeing things that appear to be random, but they're not. True randomness cannot exist. There's only order, and then there can be little instances of chaos created within order, but there cannot be just loss of order. Total loss of order is loss of existence itself. And that's because the primary structure of existence is a mind. The mind and minds of sentient beings. And a mind that is not ordered at all is not a mind. A mind's very definition is basically that which is ordered and orders. It orders your world. It takes information and it puts it into order. And in order to do that, you have to be ordered. Your structure has to be ordered. This is what I mean by, it's a theory of the structure of equations and equations. So equations would be information coming in. But then the structure in which it's organized into is the structure of mind. And that structure is also mirrored by the information that's coming in, because we're inside of a mind as well, at least according to Sentient Singularity Theory. And so there's no way to escape this. And to make the claim that the universe could have been disorder, and it's ordered. So that's evidence of, a God of simplicity and elegance. And I actually do agree that it is evidence of a God of simplicity and elegance. But the universe could not be disordered. And then he goes on to, he stated earlier than that, he said basically that essentially he doesn't believe that the God exists that smites anyone or, just wants us to have good things in our lives, or that punishes us for doing bad. That God doesn't exist. There's no personal God. Okay, well, show me the evidence that there's no personal God. And you can't say that evidence for no personal God is that I didn't get the exact, toy that I wanted on my birthday. It's a funny story real quick. I tried to, when I was young, I told my parents that the tooth fairy was not real. And they were like, yes, it is. And I was like, no, they're not real. And they were like, yeah, they are real. And I decided to come up with this test to see if the tooth fairy was real. And it was already after all the stores had closed, and so I had asked the tooth fairy for a Lego airplane. And if the tooth fairy could give me a Lego airplane, then the tooth fairy existed. But if it was just a quarter, then the tooth fairy didn't exist, and it was probably my parents because they couldn't go get a Lego airplane after everywhere had closed. I woke up the next morning, and there was a Lego airplane next to my pillow. And I freaked out. I was like, the tooth fairy exists 100%. Like, this proves the existence of the tooth fairy. And what had actually happened was my parents had a Lego airplane that they were planning on giving as a gift to either me or one of my siblings at a later time, either Hanukkah or birthday or something. And I don't want to say it was lucky, because I don't really believe in luck. But their intention with this Lego airplane was not to use it to prove the tooth fairy, and they did not know that I was going to what I was going to ask for, and so it ended up being that I had tried to falsify the tooth fairy's existence, and then come to the conclusion that that my experiment had proved the tooth fairy's existence. And in reality, it was still my parents. I'm not going to say the tooth fairy doesn't exist, even though I don't believe that the tooth fairy exists. Like, what is that? I don't even know what that is. Because I know, but that's because I know that my parents are the ones that put it underneath my coins and underneath my pillow and this Lego next to my bed. It's not enough to just say, I don't believe in the tooth fairy. Why don't you believe in the tooth fairy? Because I know that my parents put the coins under my pillow. If you didn't know who was putting the coins under your pillow, you can't even logically have a logical framework for making the case that the tooth fairy doesn't exist. But that doesn't also imply that the tooth fairy does exist. It just means that you can't argue logically that the tooth fairy doesn't exist unless you have an alternative, testable hypothesis that is mutually exclusive with the another idea. This is why I say if you're going to, you cannot disprove someone's theory of everything, really, without having an alternative of your own that predicts certain properties of the universe that are not mutually exclusive with another theory. And then you can confirm your theory, and then it would kind of, by happenstance or emergently, disprove their theory. But you don't actually go about this by trying to disprove their theory. And this is something that I've seen a lot in the Tim Nguyen does this. He's with geometric unity, and it's just the wrong way of doing it. You can't say, oh, I've disproved geometric unity because of this and this and this. Just like I can't say, well, when they go and they look for dark matter and they don't see it, it disproves string theory. No, it doesn't. And it's just the way in which you have to think about these things is very difficult to learn, and I don't know if it can be taught. It kind of has to be intuitively understood. And then you have to, have players in this who are honest enough to admit when their perspective is wrong. But and competent enough to be able to recognize it, and not just assume because somebody that they think is smarter than them said that it's wrong or right. You have to be able to recognize what is required in your goal, which means you have to first recognize your goal. Everything is about goals. In the theory of everything, you can't contextualize anything without goals, and even constructor theory starts to realize this: is that you can't start to deduce the rules of what is possible versus impossible without a goal, and you cannot. To scale this up, you cannot deduce what is inevitable by basically what are the rules of the universe without a goal. And only sentient beings have goals, but we assume that existence has no goal, and that's why we're stuck. But
no, it didn't have to be that way. Our universe is gorgeous. Think of what our universe could have been versus what our universe really is. We have conscious life.
Think about what it could have been. Try. Think about a universe of total chaos. And when I say total chaos, I mean not a universe in which anything is identifiable. Anything. At all. Not even emptiness. Not even the perception of just unending darkness. You can't do it. It's impossible to do it. It's totally impossible. Their universe could not be chaos. And, Sean Carroll has his own ideas about this stuff when he starts talking about God as well. And it's like, well, you can see it in one of my first videos on here. And Sean Carroll says all I need to do in order to prove that if you think God is necessary to the creation of the universe, all I need to do is to invent a universe in which God is not necessary to prove that God, to disprove the necessity of God, essentially. And like, basically what he doesn't realize is that if you think sentience isn't necessary to the creation, all he needs to do is to create a theoretical universe in which a sentient creator was not necessary. It's impossible. He can't do it. And there's no way in which you go about this in which order and is not the result, because there's no way to go about it in which a sentient creator is not necessary. And then the idea that it's preposterous to propose that it is necessary just because you can't perceive an instance in which it's not necessary is trying to disprove a negative, and it's not going to work. Okay, let's see. Have you ever watched any Professor Mamoto's videos? No, I have not. Supposedly, a unicorn exists in the fossil record, a large rhinoceros-type species that died out about 12,000 years ago. Honestly, a rhinoceros is basically a unicorn. It's related to horses. It has a horn. Like, don't tell me unicorns don't exist. They're just not. They just don't look exactly the way that we perceive. But yeah, you're probably right. I don't know for a fact, but I would believe that there was like a horned, animal prior to rhinoceroses that was related to horses, because rhinoceroses are. I wonder how the scenario of your parents buying the Lego airplane went down. They were like, Hanukkah's coming out. Let's go see if we can pick out a couple cool toys. Then they... Yeah, probably. I mean, I was obsessed with Legos, and I loved airplanes, so it probably wasn't hard. But I asked for... Like, they're just... What caused that scenario is my parents knew me. They knew he liked airplanes. They knew he liked Legos. Bought him a Lego airplane to give him as a gift at some point in the future. And, of course, because they knew me and knew that that was something that I always wanted, not just wanted once, like always wanted. And at that point in my life, then, of course it was what I asked for. Like, if I had asked for something that I didn't... Like, if I was going to do an actual test that was even better, I should have asked for something that I never would have wanted outside of that circumstance. And, but I couldn't do that because I was a little kid. And I had a little bit of hope that Tooth Fairy was real enough to actually, like, bring me a Lego airplane. I wonder how the scenario of your parent was. Your dad into Legos? No, I was into Legos, not my dad. Like, I was into, or my mom. But I was into Legos. My brother was into Legos, but no, not like I was into Legos. I was super into Legos as a little kid. That was like easily my favorite toy, no comparison whatsoever. Because it's not, the Legos are the toy of everything, okay? They're like the theory of everything for toys. I've never even thought about this. It's like, well, what's your favorite toys? Batman's or Legos? But what about like Lego Batman? Or like, and you could like make Lego Batman. You don't have to buy a set. Like, or like you could say, there's a Lego for every interest that exists. And if there isn't one that you can buy from the factory that fulfills whatever, interest you have, you can use Legos to make a Lego structure that fulfills the interest that you have. It is the toy of the everything toy. I'm gonna have to make a video about that. That is kind of a brilliant just realization. So I was into the theory of everything before even this. But there's rules to how you can build with Legos. You can't just do it however you want. There's rules. Like, how they fit together is governed by a specific structure. And you can't go outside of that and still have still build a stable structure with it. This is exactly true of physics. And that's why my physics models probably look a lot like Lego sets. It's just, they're Lego sets that build themselves. That's basically what the universe is. But how can you say you can't disprove unicorns, but then say, but the God that you pray to, that cares about you, doesn't exist? You can't disprove God, but you can disprove God, the God that doesn't, that cares about you and gets you what you want and things like that. You can't do that, because the God that then is the God that would get you what you want, if that God exists and cares about you as an individual and is a personal God, that God knows what's best for you more than you, or at least has power to get you what you want, or to deny you what you want over you. That's why they're God. So you can't say, well, I wanted a Lego airplane to manifest in my hands right now before everybody watching live, and if it doesn't, then that's evidence that God, a personal God, doesn't exist, because they didn't get me exactly what I wanted. That's not correct. That's like saying a personal parent doesn't exist because they don't get you exactly what you want. Parents do not get you exactly what you want. My parents got me that Lego airplane, but they definitely also did not get me a lot of things that I wanted many times in my life. Probably for the best, because they're above you in the hierarchy. Why do you guess one's the one to put in the cart and buy it? Who put it in the cart and bought it? My mom or my dad? I don't know. Like, probably my mom, given that my dad probably didn't drive to the toy store. Like, this was pre-Amazon. If it was Amazon, I have no idea. But it was pre-Amazon, so I have no idea which parent did it. But both parents could have predicted that I would have wanted a toy airplane at that point in my life. Or Lego airplane, especially. No, you say it's more likely that men would have leave it. Yes. Men would have left it up to women in those days, if they could. And that's even still the case. Like, women are more likely to make Amazon orders. I bet you if you looked at the amount of orders that get placed on Amazon and you compared men versus women, even though men do order pretty much, I order almost everything on Amazon, not everything, but a lot. The amount of things is just different. It's still, and the amount of things that I order on Amazon for other people compared to my wife is like it's like she orders way more things for others than I do. I barely order things for others on Amazon. It's like once in a blue moon because it's someone's birthday who's very, very important to me. It's just different. Women care about others much more than men. Imagine if you got every toy you ever wanted. There would be no room in your life for anything else, for any kind of life, if you got everything that you wanted. Because every time you got what you wanted, you would want something else. And there would be no gaps between it. And basically, like, you wouldn't even have the time to enjoy the things that you want. It's just almost chaos. It's almost impossible to get everything that everything that you ever would have wanted, especially if it's when you want it. But I just don't think that it's possible. It's like it's impossible to have any kind of sentience if that's the case. That's why Jesus said it's easier for a camel to fit through the eye of a needle than it is for a rich man to get into heaven. It's not about, rich people are usually corrupt and evil. It's that getting into heaven has a lot to do with like self-awareness. And I'm not saying it doesn't have anything to do with actions. It's not my place to judge that. But your actions do reflect some sense of self-awareness for the most part, usually. And if you always get what you want, or you very often get what you want, not always, very often get what you want, or more often get what you want, it's harder to self-reflect on, like, do I really need that thing that I'm struggling to get that I have not gotten? And, like, you know, am I going about it in a acquiring that thing in a, you know, in a good way? It's like you don't even, there's not that time between getting the next thing that you want to, there's not as much time between certain goals, the achieving of certain goals, to have self-reflection. And you cannot have self-reflection once you achieve a goal. Like, you have self-reflection after you achieve that goal, but not like in the instance in which you achieve that goal. That's just, it's in my work, it shows how when you're ordering information, you have actions and perspectives, and the perspectives are in between those actions, and actions are in between perspectives, and the perspectives are that which is perceived, the action, and then they dictate the action that you take, but you don't actually think about. But an action is different than perception. Basically, you don't judge an action in and of itself. You judge the results of the action and the goal of the action. So, and whether you have to have both, because you have to, in order to judge the results, you need to be able to judge them against the goal. And if you don't have a goal, then you can't judge the results, and you're not actually judging during an action. So basically, people who are very wealthy have a harder time, or they have more action. They're more enabled to take action to acquire the things that they want. And when you're taking action, you're not perceiving the results of an action and judging them against the goal of that action. And so that is what causes self-awareness. And that is very much part of what gets you into, like, heaven, or gets you saved. And when I say saved, I mean that in a super literal way. It's metaphorical and literal. It's not just metaphorical. My mom bought me the T-Rex from Jurassic Park and the White Ranger. My dad bought me hermit crabs and Lincoln logs. Yeah, my dad usually actually did. Or my dad introduced me to Legos. And it's a very male-like toy. Because it's constructive. It takes, like, outside, detached view in which to perceive that which you would want to build in order to build it. And it's the same reason there's more engineers who are men than women. Is the same reason why men like Legos more than men. And I do feel like hermit crabs versus toys. Yeah, I mean, I do feel like men are more likely to get their kids, like, something new and, like, that's not just a new toy. It's like, a fish tank. My dad was the one who got me a fish tank. My mom never got me a fish tank. That doesn't mean women don't get their kids fish tanks, but it's probably more likely to be men. But if the kids aren't the ones that desire the fish tank, because what it really is that it's the dad getting the fish tank, and the kid, and then he's saying that it's for the kids, but it's for his own satisfaction. That doesn't mean he has to even look at it. Even if he could just get satisfaction from the fact that he gave his kids a fish tank, it's not about. Whereas women are more likely to get the fish tank if the kids are asking for the fish. So when I was asking for a pet lovebird as a kid, I got this pet lovebird named Ellie, And I had that bird for like probably almost 2 decades. And my mom got me that bird because I was asking for it for a while. I had done like all this research and I wanted a lovebird. But my dad brought home the dogs that we were not asking for. Like, he brought home new puppies when we weren't asking for a new puppy. But if we were asking for a new puppy constantly, like, probably be more likely that it would be pushed by mom. And it's not about so much what is being bought. It's about the motivations. Dads are more likely to buy things that are not asked for their kids. Women, as far as like toys or enrichment, things like a fish tank or something. But women are more likely to get toys for their kids, the toys that their kids are asking for. It's just a different, that's where the mentality is. This is that type of thinking of like reframing what is actually the deciding factor is very important is going to be very important in the coming, advances. Because it's about learning where goals come from and trying to look at things in different ways from different perspectives to see in which, like, what's the perspective that would even lead to the goal that we would need to deduce the structure that we are observing or that we are hoping to observe. It's not just about, looking for, I don't know, like if you're going to look for the constraints of the universe, where Michio Kaku is saying in this, oh, well, it's up to the experimentalists to tell us the initial conditions. No. How can the experimentalists observe the initial conditions, which are basically the conditions that led to our universe, not the conditions at the beginning of the universe, but the conditions beyond the beginning of the universe? They can't, because they can't observe beyond the universe, or the observable universe by definition. So you need to understand the goal in order to understand and the context of that in which that goal is being sought, which is a sentient being that has intrinsic oneness, which is we'll talk about that in another video. Like, if you're going to deduce the initial conditions of Genesis, of the genesis of the universe, and it's modeled in my paper, but if you're going to go about it the way that Michio Kaku is claiming we need to go about it, you will not get there. You have to not try and observe them with a telescope in this universe. You have to try and predict them from the perspective of the preceding universe, and in doing that, you have to assume a goal, and also know the constraints that it's operating within, which comes from deduction of where we're going in this universe, because it's a repeating pattern. So that's complicated to dissect, but I can't get too into it because I'm gonna go over the time, like I said. Trust me, we're gonna get into all of that with the coming produced papers, where I'm not just rambling. We're almost done. And we're actually right on time. That's because I've had to stop us from going into it. I know it might seem like I'm just I'm saying like I don't have time for this as a cop-out, but...
So it's out there. Now, also in mathematics, there is a God.
But I'm not just doing it as a cop-out. Last time we went like 3.5 hours, and I said I'm going to keep it to like 2 or less. So this is he's talking about the theory of everything in physics versus the theory of everything in math, and how we're looking for a theory of everything in physics. And I think that this is the problem is that the theory of everything in physics is almost, if you're looking for a 1-inch equation, it is E = mc². And the idea that you could unite it with, the standard model in a single 1-inch equation, that's not the way that you do it. You're going to have to come up with an equation that leads to the constraints that would also inevitably evolve the equation of E equals mc squared, as well as the symmetries in the standard model. It's not that you just need a 1-inch equation uniting them. It's not about uniting them. It's about going beyond them and writing the equation, which isn't just an equation. It's an equation and a structure that is constraining and containing and contextualizing of that equation. That inevitably leads to the manifestation of the symmetries in the standard model and the equation of general relativity. But there isn't just an equation to unite them. That's just not the way that it is. And this idea that the standard model is so hideous because it's not just as elegant as E equals mc squared is a misunderstanding of a structure as part of existence, and an action, which is an equation, as part of existence. So equals mc squared, action, and structure is perspective. And so you have the standard model, which is the structure in which the actions that are that follow the equation of E equals mc squared takes place. And that's what I mean by it's like you need a superposition structure of equations that are contained within structures. The standard model is the structure in which general relativity is observed. But understanding how those unite will take a reframing of the goal. Like, you have to change the goal. The goal is, like, in order to understand which parent bought, which toy, it's not as much about understanding which toy it is. It's about, or predicting which parent bought you a toy is not so much about knowing your parent, or it's not so much about the toy that's bought. It's about the goal of the parent. So then you can say that you've reframed it in a way that allows you to realize that we have to look for different evidence, which is, if I gave you a toy, okay, and if your parents gave you a toy and you don't know which parent bought it, and you're trying to predict whether or not it was your mom or your dad, looking at what the toy is not a good predictor. Is not a good. It's not the evidence that you use to judge who bought you the toy, and because Torin said his mom bought him a Jurassic Park T-Rex and a white Power Ranger Tiger Zord. Okay, this is not something that women like. They don't know, Power Rangers and T-Rexes are generally male toys, and but yet it was bought by his mom. So you can't use the toy as the evidence, but the greater correlative, at least, evidence that you would use to predict whether or not your mom or your dad bought you a toy was, when did you get the toy? Did you get it when you were asking for it? Was it something that or not even when you were asking for it? Was it something that you asked for? Or not? And if it was not something that you asked for, it was probably given to you by your dad. And if it was something that you asked for, it was probably given to you by your mom. But you need to understand the goals of the sentient beings that are responsible for these actions in order to make more accurate predictions about about these actions and where they're coming from, and it's like circular. But that's why in my paper, it basically explains why you almost have to have figured out the theory of everything in order to judge the theory of everything, or a theory of everything, or to deduce how you would judge it. Because you can't understand these things otherwise. You're just looking at like, well, did my dad buy me the T-Rex or did my mom? But the thing is, as an outside observer, who knows nothing about your family, knows nothing about your parents, knows nothing about you, just sees that, some T-Rex toy was bought. And if you said, well, predict if this was bought by their mom or their dad, you can't predict from there. You can predict the gender of the child, but not the gender of the parent. You can predict the gender of the child who received the toy, by that bit of information, but not the gender of the parent who gave the toy. If you're going to predict the gender of the parent who gave the toy, then you need a different bit of information, which was this something that the child asked for? If not, probably given by the father. If so, probably given by the mom. That is that way in which you realize, like, you cannot get from type of toy to gender of parent who gifted the toy. But you can get from type of toy to gender of child receiving the toy. What that shows is that not every path is a path that you think would be a path is a path. Okay, so the idea that experimentalists with telescopes or with hadron colliders or particle colliders are the ones who are necessary in order to, deduce or perceive or figure out the initial conditions of the genesis of the universe is wrong. It's like trying to predict which parent gifted their children a toy based on the type of toy. You can't. You need a different bit of information. You need to reframe the problem. And this is something that's very hard, especially, and it's increasingly difficult for people these days because school is not rewarding of people who are actually good at thinking. They are rewarding of people who are good at memorizing and who don't challenge the narrative. Because if you're going to, always give the correct answer, who's the judge of that answer? The institution. That means that you have to give an answer that is already been taught to you by an institution. And if you're doing that and that's how you're judged, then you're literally not being judged on your ability to think. And this is the problem with our current establishment of everything, is that it's a bunch of people who have been put into positions of influence and labeled experts by institutions that have incentive structures built into them that reward conformity to established ideas, which you cannot do if you are actually good at thinking. You can't do it. And to end that, I'm going to give Michio Kaku credit because he actually said the exact same thing that I just said. Basically. Not exactly, but it's related in this final clip. And then I'll take questions, and then that'll be it. We actually got through a lot.
Fear of scientists known to science. The greatest destroyer of scientists known to science is junior high school. When you go to junior high school, science is made boring. Science is made memorization. It's having to know things that are totally irrelevant to people's lives. You know in the back of your mind that you're never going to use that piece of knowledge ever again, and you're more or less right, science is not relevant to people, and science becomes giving names to things. Richard Feynman, the Nobel laureate, told this story that when he was a child, his father would take him into the forest and show him how birds evolve, coloration, beak, how they feed, and so on and so forth. And one day a bully comes up to Feynman and basically says, "Hey, Dick, what's the name of that bird over there?" And the young Feynman did not know the name of the bird. So I'll paraphrase. The bully then says, "What's the matter, Dick? You stupid or something?" And in that instant, Feynman realized the difference between science and the appearance of science. That science is about principles, concepts, physical models, and pictures. That's what science is about, not giving the names to birds. Of course, you have to know some names, but that is not science, giving the names to things. And so I think that's something that we have to realize, that young children were born scientists till it's crushed out of them when they hit junior high school.
Reminds me of a joke that I sometimes tell.
Brilliant. And I wanted to end it on something good because him and I have a lot of, I don't even want to say disagreements, but we definitely, I take issue with some inconsistencies in some of his statements, and we don't agree on everything. But it's not even that we don't agree; it's that it's on like what is the truth of certain things. It's that it's just about consistency across. We disagree. We don't even disagree. I take issue with the inconsistency of the application of concepts that are labeled and stated in one way over here, and then are actually acted on in a different way, but not consciously. But that's a problem with not even just the entire field of physics. It's every field right now. But Michio Kaku is somebody who sometimes says absolutely brilliant things, and a lot of his metaphors I actually agree with and think that I take them more literally than he does, probably. Not even probably, I know I do, because of his explanations about him. And I think that he's a very valuable mind, even though we disagree on some things, and I also take issue with methodology and of involving other things. I think that he's got a lot to add, and I've always come away from hearing his interviews with a new and important bit of information, whether he tried to give it to me or whether or not I ended up realizing it due to something that he said. And so I'm not here to just rip anybody down. I think, like I said, very important mind. And on a lot of core things, I do actually agree with him on. It's just with the breakdown comes in the inconsistent application of certain concepts. But he's very right, and that's and what he just said is probably it's the biggest issue that I have with the anything involving our scientific or academic institutions, and it is a huge issue for me as somebody who really did not do well in school and realized that school was not doing what was not incentivizing what its stated goals were. And my mentor in science, as you could say, is a ecologist, biologist, zoologist, herpetologist, who is absolutely brilliant when it comes to understanding wild animals and captive animals to a level that I've never seen in anyone else. It's kind of remarkable. And it's not even kind of remarkable, it is remarkable. And that person taught me that the importance of asking good questions, and also early on I saw a lot of things that were wrong with what our academic establishment is calling science. And it's very important that we start to recognize the difference between, it's not the difference between science and not science. That's the problem. Everything is science. If science means truth, or the attempt at getting to the truth, then everything is science. And if it doesn't mean that, then nothing is science. But what we need to say is we need to reframe this and say that we're not teaching thinking. And I don't know if you can teach thinking. You need to give an environment, provide an environment in which somebody can learn how to think. It's not about being taught how to think. You can teach the scientific method all day long, but then people will misapply it and not apply it, and it will just, that doesn't mean they can use it practically. And the scientific method is just the externalization of the thinking process. And I've mapped this thinking process in my work, and then realized it was the internalization of the scientific method. The scientific method is the externalization of the thinking process. But I am not, even if you gave somebody this diagram and this decision tree, essentially, this model of thinking, and they studied it, it doesn't mean that they would actually be able to apply it. You need to provide them an environment in which it fosters and encourages and rewards application of this idea. And we don't do this for any schooling, and I think that school is destroying scientists. It is labeling people as scientists, some people as scientists and some people as not scientists, and then it is actually, those people that they're calling scientists are actually not very good at thinking. And the people who are better at thinking are usually the ones who don't do so well in school. And it's a shame that and it's a problem that we really need to correct, at least in, the pockets of people that we want to. I'm not saying you can correct it for everybody, because, like I said, you can't force someone to think. You can't teach somebody how to think. You have to allow for them to think in an environment that encourages thinking. And our school is about memorization. And this idea of, science is just giving names to things. I remember when I was in college, I listened to Stephen Hawking all the time, and I thought that I, knew physics better than people who didn't take physics classes, because I've never taken a physics class. And if you asked me, what's the theory of everything, I would have been like, dude, string theory. Like, there's actually 11 dimensions. Isn't that crazy? And cat is alive and dead at the same time in some box, and also it's a particle and it's a wave, and it doesn't make any sense, but that's what's true. Don't you realize? If you don't know that, then you're just not, you don't know science. And if you think that the universe was created by God in an act of conscious creation, then you don't know science. But if you do know that the universe came from the Big Bang, even though it didn't, then you knew science. It's I wasn't thinking. Even me, who was objectively, just honestly, fairly good at thinking. Better at thinking than most people. And that's not an IQ thing. That's something that you learn. So anybody can be that. This isn't a statement of being braggadocious or something. You can learn how to be better at thinking, but it has nothing to do with your IQ. It just has to do with practice. And I still was failing miserably. And that's because when we don't know a goal, and we don't understand that it starts with sentience, then you can't form goals. If you can't form goals, then you can't judge concepts. And then you start saying that, the Big Bang is where the universe came from and not God. When it could have been both. Who caused the Big Bang? It's not the right idea even. It's not that one is right and one is wrong. It's like you need to realize that you need to reframe the problem. And my final example of this is once I had asked my then girlfriend, but now wife, I was an atheist, a self-described, but really an anti-theist. But I called myself an atheist, and my girlfriend was a Christian, and like faithful Christian. And once I had asked her, because I mean, evolution and the biological and ecological world is, and the study of biology and ecology is a huge part of my life. And I asked her, do you believe that God created the universe, or do you believe in evolution? And she looked at me and she was like, both. And I was like, those aren't really mutually exclusive ideas. And I'd never considered that in over 24 years of life prior to that moment. That is what I mean by, sometimes to get to the actual truth, it's not about judging what is right and what is wrong. It's about finding the correct framework in which then you judge from there. You can't actually even know what to judge or know what you're judging without the correct framework. So that's it. Let me answer some final questions and then I'll go. It seems like random stuff, but it's all related. Yeah, it seems like random stuff, but it's all related. You can't say, this is my biggest problem in these streams that are live, is basically like going off in different directions, but they're not really different directions when you're talking about the theory of everything. If your stream was about playing the violin, and you were talking about like the geckos that you got this past weekend, and them looking at themselves in the mirror, or in their reflection, or seeing themselves in seeing their reflection, then you'd be like, this guy is just going off in all kinds of random places. But the rules are different when you're talking about a stream that is dedicated to the deduction and description of the theory of everything. And so you have to judge it differently. But it also means like you have to approach it differently as well. But you need to know the goal of the stream in order to know whether or not you can judge it a certain way or not. You can't judge me for not playing ukulele the entire time if it's not a ukulele stream. And that's true. That idea is consistent everywhere. It is as applicable to Shakespeare and literature and storytelling as it is to physics and politics and chemistry as well. And we just don't take that idea very seriously of a theory of everything. We don't really know what it is, as Eric Weinstein has said many times. But that means that you have to say what it is if you do know what it is, instead of just saying, we don't know what it is. How much do you accept anyone from the mainstream? I mean, you have to give me a name. And you have to, it's not even about giving me a name of how much I accept them. You have to give me someone from who would be probably, described as the mainstream, and then you have to ask me which idea of theirs to judge and whether or not I agree with it. Then I can actually tell you. But to say, like, the question matters, not, picking on you, but like this is a good example of like, how the importance of the framework of the question if you're going to get a meaningful answer. You have to say, do you agree with Michio Kaku's idea that, that God is not personal God and would not care about much about our existence at all? Like that you could say, and I will give you that answer. But you can't even say, well, how much do you agree with Michio Kaku? On what? Like, I agree with everybody on some things, and I disagree with everyone on some things. There's nobody that I completely agree with or completely disagree with. And that of course, that's that's the way it should be. If you don't think that if you don't follow that perspective, or you don't have that perspective of you agree with everybody on some things, you disagree with everybody on some things, then if you agree with someone on everything, then you are idol worshiping them. And if you disagree with someone on everything, basically also idol worshiping, but it's like a backhanded idol worship, and it's really that you're misjudging, and which means you're judging from a perspective in which you should not be judging, or you're judging something from a perspective in which you should not be judging that thing. And neither are good. Everybody has meaning, which, if that's true, you have to admit that you agree with everyone on something. This is random, but did you know that aside from Gila monsters, bearded lizards, and Komodo dragons, most monitors and iguanas are venomous? Yes, I did know that. Brian Fry did that research a few years ago. Or some years ago. This is just random at this point, just answering questions, so... but we got through it in almost 2 hours. Please hit the like button, subscribe. Links are below to my website, Patreon. If you want to join our Discord server, then message me on Instagram privately and I'll give you the link. We host a weekly live call that is open topic, and it's always a really good time. Also, the link to the video that I just gave, some of my commentary on is linked below. I highly suggest that you watch the entire thing of it. Don't just take my word for what, the context of these things, even though I did my best to be honest about the context of these statements. And definitely subscribe to Brian Keating's YouTube channel. Brian is a very good thinker, and he not only, I'm not just saying this because he's a friend of mine, but he's brave in his willingness to entertain certain people and certain ideas that are not accepted by the mainstream, and he is part of the mainstream. So very much I'm grateful for that. Do you think there's anyone in the mainstream that's particularly trustworthy? I don't know what that means. I disagree with Brian on physics quite a bit. We've had debates about it, and I think that he's wrong about some of the things that he has said. But that's without getting too into the weeds about what he means by certain things versus what I mean by certain things. But I very much agree with his approach, and that's more important. That's much, much more important. So trustworthy doesn't mean people that you can take their word for it, but it means people who are trustworthy have a better perspective on how, or a better approach. And I think Brian has a better approach than most people in the mainstream. So if you're asking if there's anybody that's particularly valuable in the mainstream, Brian Keating. I've not joined Bob's Discord yet, but I would like to. You should send me a link to it on our Discord. But I think that's everything, and I'm going to say goodnight and get off. I will not be having any stream tomorrow. Like I said, the new schedule is only one live a week, but we will start coming out with produced content as soon as I'm done with my paper. I will be hosting the live call at 7 p.m. Pacific time on Thursday. For anybody who wants to join. Like I said, it's open topic, and we can discuss anything that you want. And it's a much more just intimate and also open environment than this one. It's not just questions about what I'm talking about from a chat. It's you can speak to each other, to me, in your voice about any topic. There's never a topic that is the topic of discussion that anybody has to stick to. And it's about making connections with people who have the same interests. And, the people in our lives are the real value in our lives. And, or value, the reality of value is that it's personal. That's what I'll say. All right. Peace, everyone. And I will see you next week.